Welcome at this video where I explain how to test the correlation among nominal and ordinal variables and between interval variables and multiple groups. So we will discuss this video is a cross tabulation and the ANOVA test. So here's an overview of all the different test statistics that you can use. If your dependent variable is nominal, meaning it has two values, for instance gender, men and women, you would need the chi-square value. If it is ordinal, meaning for instance education with three variables, 3 levels or 4 levels, that would be considered ordinal, or maybe marital status, which would be multinomial, as there is no ordering between the categories. You would also need the chi-square value. If you have an interval ratio level variable, like the income scales that we used in the last video, then depending on how many groups you want to compare, you would need the t-test or the ANOVA test. If you compare two groups, meaning for instance gender, you would need a t-test. But if there are multiple groups, which can be interpreted as a multinomial variable, then you would need an ANOVA test. Lastly, if both variables are measured at the interval level, you can use a correlation. So a cross tabulation tests the relationship between nominal or ordinal level variables, or you compare two or multiple groups. There are no dependent or independent variables, so it does not matter which ones are the rows and which ones are the column, not for the statistics. So how can you get SPSS to run a crosstab? You of course can go to Analyze, Descriptive Statistics and Crosstabs, but I will show you how to do it in syntax. Crow, I want to compare the way how people view themselves as a world citizen by marital status. I also would like to have for each cell the count, which is the observed frequency, the expected frequencies, and the row percentages. Additionally, I would like to have the chi-square value. So one thing that I have not discussed that with you, but similarly to the t-test and the correlation, you also test a null hypothesis. The null hypothesis in this case is that there is no relationship, similarly to the correlation. So if there would be no relationship, you would view that these expected frequencies are very close to the observed frequencies. If that would be the case for each cell, you would get a highly non-significant value of the chi-square test. However, as you can see here, there's quite a substantial difference between these observed and expected frequencies, and therefore this chi-square value is very high. It's 69. With a degrees of freedom of 15 means that it is highly significant. We go back to the formula. Here you will see that actually these differences between the observed and expected frequencies for each cell, those are squared and divided by the expected frequencies. These numbers are summed across for each cell, and together this makes this becomes the chi-square value. The degrees of freedom depend on how large your table is. So you multiply the number of columns minus 1 times the number of rows minus 1. A chi-square value also, so for 1 degrees of freedom it has this distribution. And the more degrees of freedom you get, the larger your crosstab will be, the more flat the distribution will become. Now, using the degrees of freedom and a specific value of the confidence interval, you obtain a chi-square value. From in this table, you see chi-square value, and this table is actually the border. So if you obtain a larger chi-square value than this one, This means that in a 2 by 2 table with a degree of freedom of 1, a larger value than 3.84 would mean that there is a significant relationship between the two variables. Now in our case we had 15 degrees of freedom, meaning that the border relationship would be 25, but we obtained a chi-square value of 69, which is highly significant therefore. So now we go on with the ANOVA test. There we measure the variables at the interval or ratio level, and this is usually this is the dependent variable, and we compare multiple groups how they measure on this interval variable. So first, if you want to conduct an F-test, you just type in one way, which is short for one-way ANOVA. And we test the income. And we test it by the marital status, which would be recognized by SPSS as a group variable. So here we see the ANOVA table. The ANOVA table depicts the sum of squares of the between group variance and the within group variance, and the F value with the significance value next to it. So let's go to the formula. So the formula of the F ratio, the F test is usually interpreted as the ratio of the explained versus the unexplained variance. Now, what do you really want to know with an F test? You want to know whether the differences between groups are larger than the differences within groups. So that's actually what you compare. You compare the differences between groups, the sum of square errors, with the sum of squared errors within groups. Now, the degrees of freedom are different for between groups and within groups, depends on the number of groups, or the sample size versus the number of groups. Now, in our case, the F value is 5, and similar to the chi-square value, it follows its own distribution, has its own table given the degrees of freedom, and according to this table, our F value is significant. Meaning that the marital status, the people with different marital status have a different income level. So if you also want to include some more statistics, you could use So if you want to know more about the F value, I advise you to look at the statistics. You can also test the homogeneity of the variances. Oh, I forgot. So here you have the Levene's test of the homogeneity of variances, similar to the t-test that we saw before, where we compare two groups. We also assume that the variances are equal in this test. As you can see, it is not significant, meaning that the variances can be considered equal. Now, in this first table, the descriptors, you see the mean, and these are actually tested in ANOVA. We test whether these means are different given the standard deviation of these groups. Now, as you can see, the single people have the highest income, after that the married people, and then the separated people and divorced people. Lastly, living together as married, and the widowed people are the poorest in the sample.